Okay. And what is the measurement of the voltage? It measures in volts. We say some that we said these things sometimes that a 256 volt 256 voltage will is light current is coming from the main source. So this is the thing. And if we have to measure the in a closed circuit, we have also a voltmeter in which we can measure that how much voltage is moving a circuit does have. We can measure that by attaching a voltmeter to that circuit, same like as current ampere meter. Okay, and after that we have next thing is voltage, as it is measured in volts. And after that finally resistance, which is exactly what the name suggests. Okay, we in a normal daily life we use this word resistance. Okay, there is some kind of resistance in her voice, in her attitude, in her personality. We use this in a very basic things. Okay, so resistance, so that is denoted by a capital R. Everything is just mentioned in this name. Okay, what is the resistance? It's everything that resists or opposes the flow of electrons, similar to partial blockage in pipe. Example, it is measured. For example, if we have, okay, if I give you an example that we have a line of, we have a pipe. If we have to water the plants in the garden, we will just turn on the tap, and because the high pressure, it means that we have a closed circuit in which the electrons are traveling. The current is traveling just like the water is coming from the pipe. Okay, if there is high and low, that tells about the voltage of the water that is coming from the pipeline. For example, if you put any blockage in the mouth of that pipe, a very little bit or sometime it won't, water will come out from that pipe. So this is an example. This is a blockage of a current. If the current is traveling in a current very fast and very high current, if we want to load that current, if we want to decrease that current, if we want to oppose the direction of that current, we use the resistor. Resistor is basically a device which if we increase the resistance, current will be low. If we decrease the resistance, current will be high. So it means that we can say that current and resistance have which kind of relationship? It is direct or it is inverse. I told you about these relationships. When something increases, another will decrease. If that one increases, other will decrease. It is inverse or direct relation. Which kind of relation? This is inverse relation. Which relation? Inverse. Yes, inverse. So we have to write the definition. Everything that resists or opposes the flow of electrons. Everything that resists or opposes mean oppose the if it is traveling in the right direction, it will opposite direction to the left side. Okay, or oppose the flow of electron. Flow of electrons. Okay, you can simply say that, for example, this is the path of a current for electron that are traveling. There is a blockage. It means that they will go back. Okay. So after that, now what is the unit in which unit this resistance will be measured? This the SI unit of the resistance is ohm. Have you ever heard about this name? Ohm's law. No. So this is the upper unit of resistance is ohm. As I told you this, the resistance and current has for example, this is Ohm's law, okay, in which current has a direct relation with the voltage. This is the Ohm law. So before starting that, first thing you have to understand that in a current, in a circuit, when current is traveling, when we shows at any kind of deflection, any kind of changes, and whenever the current will flow in any circuit, in any wire, in any conductor, it provides two things. it will travel electricity, and it will also travel heat energy as well. So whenever you touch that in which the current is traveling, and the another thing is it will light up or it will get heats up because of the energy that is traveling in that circuit. So we saw three components: cell, battery, filament lamp or bulb, and the last one is the switch. So we also learned the three quantities in which on which that is travel in the circuit, that is present in the circuit: the current which is traveling in the circuit because of the movement of electrons, and the voltage, the potential difference which driving the electrons. Okay, and another and the last one is a resistance which opposes the flow of electrons that is traveling in the circuit. So after we have got the concept of the resistance, current, and the voltage, now we have to look down the formula of these three quantities. The formula is given by a scientist. So now we will go to the basic concept and a very basic idea about what is Ohm's law. So we have to understand that what is an Ohm's law? Ohm's law is basically applied in a circuit, applies in a graphs. Okay, Ohm's law, the voltage across a conductor is directly proportional to the current flowing through it. This is the formula right in front of you. This is the definition of Ohm's law. So we put Ohm's law in a circuit. Okay, Ohm's law means if object shows ohmic resistance, ohmic relation, that is the ohmic, that circuit is belongs to the ohmic group. If they don't, they are non-ohmic. Okay, and what is Ohm law? In which current is this is the current is directly proportional to voltage. Okay, so in physics we don't use this proportionality sign. If we have to replace it, which quantity we use? Do you have any idea about it? We use a proportionality constant and we call that R. Why we use R here, but in the spring system, in the spring mass system, in pendulum, we use K, because according to the condition, that K is adjust with the pendulum, with their length, with their gravity, and it has a maximum value which is concluded in that system, in that experiment. So if we are going to study about any circuit, if we are going to study about the resistance, the current, the voltage, and the temperature, we remove the proportionality constant with the R, because here R is represented as the resistance in the circuit. Okay, as you can see here, if we have to replace this quantity, it means that R will be here. Okay, if we replace this quantity, just replace the position of them. R is here, which is the resistance, and V is now multiplied with R. When we multiply something, we have to adjust that multiplication into division. I then V will be here and I will be here. Now, here you can take a look. R is direct relation with V, but it shows inverse relation with I. So you can write like here, I. It means that whenever resistance increases in a circuit, then the current will be decreases because of this inverse relation. If the resistance decrease, then the current will be increase. This is a little bit idea about the Ohm's law, which which told us that in a closed loop, the current is traveling has the same voltage. If the voltage increases, current increases. But when we remove that proportionality constant with the resistance make an inverse relation with the current and direct relation with the voltage. If voltage increases, resistance will also increase. But if we increase the current, resistance will decrease. Okay, so after this we have to do similar after partial. I'll give you next thing we have, it is measured in ohms and it is denoted as like this. It is denoted as like this. Okay, this is sign of ohm. So the last The last thing we need to cover is which way around the circuit current flows, which is the direction of the current. So if you look in this diagram, it has one longer line and another one is a shorter line. Longer line in a cell or a battery is always be the positive terminal. Okay, whereas a shorter line is always a negative terminal. As I give you the look of the circuit, so we have a longer side which is the positive terminal and the shorter side which is a negative terminal. Okay. Okay, know what is the direction of current, in which direction the current is flowing in the circuit. So next thing is now because the electrons are negatively charged, they flow around the circuit from negative terminal to the positive terminal. Okay, so the electron is traveling in the circuit. So it's mean that, for example, if we have a circuit, there is a positive, there is a negative. Here we have a filament bulb. And here I draw the one switch. So this is a positive terminal, this is a negative terminal. As electrons are negatively charged, it means that when the current is provided to that source, the current will be start from the negative terminal and then it will goes to the positive terminal. Okay, and this circuit will continuously start moving. However, when people first discovered the electricity, they didn't know anything about this. So they decided that the current flows from positive to the negative terminal. Before, if we talk about the ancient time, the history of the physics, they don't know about the electron. They just draw and they get the concept of a circuit. So when they got the concept of electron, because it's negatively charged, they tell us that in a circuit, current start from the negative terminal that goes toward the positive terminal. But before that, they tell us that they told us that the current is starting from the positive terminal and going to the negative terminal. Okay. So keep this convention, sometime calling it a conventional current. So that electron which is coming from the negative to positive, we call that is a simple current. Okay. You have to write it down. When Now after the lecture, you just have to understand this thing. We have two types of current. Okay, in the circuit. When current travels from negative to positive. This is a simple current which is traveling in a circle. Okay. Okay. When this is the first point. This is the first type, and this is the second type. When current travels from positive to negative, we call that current as a conventional current. Okay. Conventional current. So even though it's a bit weird, just remember that for your this is thing is just for the exam, okay? And you just have to remember that always current is traveling from the negative terminal to the positive terminal. So this is the